Day 2 double angle identities. Today we're going to be solving using the double angle identity. So when we look at the first question, we have a couple of things we need to notice. First of all, we are asked for all solutions. So since we're asked for all solutions, we're going to be using that notation of plus 2 pi k, where k is an element of integers. And just keep that in the back of your mind. We look at the question and we know eventually we're going to be solving for x. We have a double angle right here. Now with the cosine, we need to make a decision about which one we substitute in. Well, since we already have a cosine in the other term, I'm going to pick to replace my cosine 2x with the double angle formula that also has cosine, because then I have consistency in my equation. So that's how I go about determining which one to pick. So my first step is I'm going to replace this with 2 cosine squared. And I'm going to use x, not a, because x is given in the question. Then I'm just going to proceed with the next term and set it equal to the -1. Now I need to eventually solve. So I'm going to get rid of my 1 here. And then I look at the left-hand side and I say, what is common between these two terms? What can I factor? So I can't factor out a 2 because the 2 is not the same as the root 2, but I do have cosines in each term. So I'm going to factor out a cosine. And now I have 2 factors that are equal to 0. So I'm going to use the zero product property, meaning that I take each factor and I set them individually equal to 0. And then individually, I take each equation and isolate x. I bring the root 2 to the right-hand side, so it's going to become negative, and then I divide by 2. Now I need to evaluate these, so I'm going to look at my unit circle. So the equation on the left-hand side is asking the question, cosine, so that's the x value. So at what angles is the x value equal to 0? So I look at my unit circle. My x value is equal to 0 at pi over 2 and at 3 pi over 2. So pi over 2 and 3 pi over 2. And then my other equation is saying at what x values do we have, at what angle is the x value negative root 2 over 2? So negative root 2 over 2, I have 3 pi over 4 and 5 pi over 4. So I found those by evaluating with my unit circle. So if the question said, what are all the answers within the specific domain of 0 to 2 pi, I would be done. But that's not what the question is asking. It's asking for all solutions. When we go to all solutions, recognize that with our pi over 2 and 3 pi over 2, those are actually on the y-axis, both of them. And we can simplify our notation at the end rather than writing pi over 2 plus 2 pi k and 3 pi over 2 plus 2 pi k and having two different equations there for our solutions. We can actually simplify that and write pi over 2 plus pi plus pi plus pi plus pi. It gives us the same answers and it's more simplified. So we're actually going to write pi over 2 plus pi k, where k is an element of integers. And that will incorporate that 3 pi over 2. The next ones will actually stay the same with 2k pi. And why can those not be simplified? Because we actually need that full rotation to come back to the starting position and find the coterminal angle. So 3 pi over 4 plus 2 pi plus 2 pi plus 2 pi and 5 pi over 4 plus 2 pi plus 2 pi. If we didn't do the same thing and we actually put pi, then we would get an answer that's actually not one of our solutions. So let's say we picked 5 pi over 4 and we only added pi, then that would get us here, which is not actually a coterminal angle for our original angle. So if you need to rewind that because it's helpful to see that explanation, and again, make sure that you do that to fully understand. Next question, find all solutions to the equation root 2 cosine x minus sine 2x. So we do have a double angle here. And again, we're asked all solutions. So the first things first, sub in that double angle identity. This time we don't have to pick, there's only one. Great, that makes our life easier.
Barbecue all day long. Just don't stand where they're going to be flying over you.
Okay, so then we look at what is common in each term. What can we factor out? So it looks like cosine is common. So we're going to get root 2 minus 2 sine x is equal to 0. We have our two factors. We'll use the zero product property. Just like before. And then we'll isolate our x. So if I bring that root 2 over, I get negative root 2, divide by negative 2. So it simplifies to be a positive root 2 over 2. And then isolate our x. So then we go to our unit circle to evaluate. So we're looking at what angles do we have our x value equal to 0. That's going to be, again, pi over 2 and 3 pi over 2. And then our other equation, where the y values equal to positive root 2 over 2. Positive root 2 over 2 would be pi over 4 and 3 pi over 4. Now, again, if we're asked for a domain from 0 to 2 pi, those would be our answers. But we're not. We're asked for all solutions. So then we need to simplify. We have that same situation where we're on the axis. So instead of doing pi over 2 plus the coterminal of 2 pi, we're just going to add pi. And then we'll follow suit here. Pi over 4 plus, we need to add that rotation of 2 pi. And sorry, that went off screen a little bit. And those are our final answers.